Hello everyone. In this video, we will discuss gravitation. Gravitation is the phenomena which occurs between two objects due to their masses. These two objects attract each other with equal magnitude of force but opposite in direction. Let's write it. So we can write gravitation is the phenomenon which occurs between two point objects due to their masses. The force acting between two objects are equal in magnitudes and opposite in direction. Okay, any object in the universe attract each other due to their masses. Okay, now right. According to Newton's law of gravitation, the force of attraction acting between two point masses are equal in magnitude, opposite in direction. These two forces act on different objects. For example, if we have a point mass m1 and another point mass m2, then m1 will attract m1 will attracted by m2 by force f2 and m2 will attracted by m1 by force f1. These two forces are opposite in direction. We can write here f2 vector equal to minus of f1 vector, or f1 vector is equal to minus of f2 vector, but their magnitudes are equal. Okay, now what is the statement of Newton's law of gravitation? First statement is the force of attraction. This force of attraction acting between two point masses are directly proportional to product of magnitude of their masses and inversely proportional to a square of distance between them. These two are the statement for Newton's law of gravitation. This law works good for point masses only, but universal law of gravitation is valid for everywhere in the universe. For any object having mass, we can apply Newton's law of gravitation. So we can now write F is directly proportional to product of masses of two objects and inversely proportional to these two forces are equal. Okay, so we are writing here F is inversely proportional to a square of distance between these two masses. For example, we have m1 mass and this mass is separated from mass m2 by a distance r. So force acting between these two masses are equal and opposite. F is directly proportional to product of magnitude of masses and inversely proportional to a square of separation between them. Now combine equation 1 and equation 2. We are getting F is directly proportional to m1 into m2 over r square. On combining these two equations, when we remove proportional sign, then we have to introduce a constant of proportionality for this equation. For this equation, we have constant of proportionality G, which is called universal gravitational constant. This is m1 m2 divided by r square, where G is called universal gravitational constant, and its value is G is equal to 6.67 into 10 to the power minus 11. We can write its unit as multiply both side by r square, the Newton meter square, divided by kg into kg square. So this will be unit of G, Newton meter square per kg square is the unit of universal gravitational constant. Take some example to illustrate F equal to G into M1 into M2 by R square. Suppose we have, this is valid for point mass only. Okay, suppose we have a point mass 2 into 10 to the power 5 kg point mass, and this is separated by distance 2 meter from mass 3 into 10 to the power 6 kg. Then what is force of gravitation acting between these two point masses? Both will experience same force of gravitation no matter which mass is greater. Okay, we have already discussed here. We have two different masses m1 and m2, but these two are experienced by same magnitude of force in opposite direction. In same way, both will experience same force of attraction F. We have to find out value of F. So F can be written as G into M1 into M2 over R square. Value of G is 6.67 into 10 to the power 11 into masses is 2 into 10 to the power 5, 3 into 10 to the power 6, and separation is 2 square. Okay, so we have F equal to 6.67 into 10 to the power 11 minus 11, sorry, minus 11 into, this will be also 10 to the power plus 11, and 2 3 is 6 over 4. These two will cancel each other. We have 2 2s, 2 3s. Now we have 3 7 is 21 by 2. So we have 10.005 Newton of force acting between, approx 10 Newton force will act on each mass due to gravitational phenomena. Okay, so 10 Newton is the force acting on each mass. Take some more example to clarify Newton's law of gravitation. Suppose we have 2 point masses initially separated by distance r. Now this separation becomes double. That means keeping the same masses but separation gets double. This will be 2r now. Then if initially F force was acting between them, now what force F prime will act between these two masses? So we can simply do this. Let's say this is F1, this force is F1, both are equal. F1 can be written as, by Newton's law of gravitation, G into product of their masses m1 into m2 and over a square of separation. So this is equation 1. For second situation, second case, F2 or F prime is the force acting between 2 point masses. This will be G into m1 into m2 over twice of r whole square. This can be written as 1 by 4 into G into m1 and m2 divided by r square. This is equal to F1, and F1 is F. So F by 4 force will be in second case. That means force is reduced by factor 4, 1 by 4. Okay, force will now only 1/4 of the original force. Take one more example to clarify Newton's law of gravitation. Suppose we have 2-point masses. Example 3. 2-point masses are separated by distance r. This is point mass m1 is equal to m, and this one is m2 equal to 3m, and separation between them is 2 of them is r, and a third mass m0. Where should it be placed so that it does not experience any force? If we put this m0 at the left side of m1, then what will happen? M1 will attract in this direction, M2 will attract in this direction. So in this scenario, there will be never zero force acting on M0, because these two forces will added up. So it can't be zero. In similar way, if we put M0 here, then M2 will pull it with greater force, and M1 will also put toward left with some force, and these two forces will be added up. So no force of so there will be no chance to have zero force acting on M0. So we cannot keep this M0 either left side of M1 or right side of M2. So we have to put anywhere in between mass M1 and M2 this M0. Let's say from M1 mass at x distance we put or keep M0 mass, so that net force acting by M1 and M2 is 0 on M0. Let's say M1 exert F1 force on M0. So force of gravitation is attractive force. So F1 force will act in this direction, and M2 will attract in this direction. Okay, this M0 will closer to M1 because M have a smaller mass. 3m is greater that of m. Okay, we will make it sense at the later part of the solution of this question. But m0 will have zero force only if f1 minus f2 is equal to 0. In another word, if f1 and f2 are equal in magnitude, opposite in direction, then net force acting on m0 will be 0. So we can write here f1 is equal to f2. Okay, now f1 can be written as g into m1 into m0 divided by separation is x, g m1 m2 divided by x square, and equal to f2. F2 is force between m2 and m0. A separation is now m0 and m2 is total separation is r. X will subtracted. So r minus x is the separation between m0 and m2. Product of masses m0 into m2 divided by r minus x whole square. m0 g will get cancelled out. We have m2 as m x square divided by x square. Now this will be 3n over r minus x whole square. Okay, m2 is equal to 3n, and their separation between m0 and 3m is r minus x. This m will cancel out. So we have 1 by x square is equal to 1 over r minus x whole square. Take a square root both sides. We have 1 by x, 1 by r minus x. Now r minus x Here is the 3. 3 was missing. So this will be root 3. Okay. R minus x, do cross multiplication for this equation. R1 into r minus x, and this is x root 3. Separate x in right side. We have r is equal to x plus x root 3. We have r is equal to 1 plus root 3. So we have x equal to r divided by root 3 plus 1. We can rationalize to get another answer, no problem. This is the our illustrations for Newton's law of gravitation. In next video, we will discuss acceleration due to gravity. Okay, but some conceptual questions. If someone says plane, a ball or a pin is attracted toward the earth, but earth does not pulled by this pen. What is the reason? While we know that the force exerted by earth on a small ball is same that force exerted by earth on the ball. Once again, we can say here, this is the earth and this is the ball. When we release this ball, the ball is accelerated toward the earth, but earth is not accelerated toward the ball. What is the uh, case between them? What is the uh, actual concept behind it? Okay, what is the facts? Suppose this ball have mass m, and this earth has mass capital M. Ball is accelerated toward the earth, but earth is not attracted or accelerated toward the ball, because both since force experienced by earth on ball is equal to force experienced by earth. But when we calculate acceleration of ball, then force is greater and mass is smaller. So it seems uh, that ball is accelerated toward the earth. But in the case of earth, force is same as a ball is pulled by the earth. But in the case of earth, mass is very greater in comparison to mass of the ball. So this acceleration is nearly zero. So that's why earth is not attracted toward the ball during free fall. This is the uh, facts. Okay, see you in next video. Thank you for watching.